Hello and welcome to this tutorial for VRED Core. I'm your host Christopher, and today I continue the tutorial on use cases and automating tasks with VRED Core that we started in the last video. I will show you how you can build pipelines that render scenes, convert files to another file format, and optimize your scene graph using simple automation scripts that process multiple files all at once. There are many different ways to write automated scripts for VRED Core, and it also depends on your operating system, your use case, and many other factors. That's why there's no correct way to write scripts, but there are good and not so good ways. In this tutorial, I will use Python scripts to automate VRED Core pipelines, but you could achieve the same result with a batch script on Windows or shell scripts on Linux. Or a whole different approach. This is just to give you an idea about what you can do. I'm using the Visual Studio Code environment, which is free to use, with the Python runtime installed on my system. With the press of a button, I can run my scripts and immediately see the result in the terminal. Let's start with the first example. I want to convert all files in a directory to another file format. In the last tutorial, we learned about the pre- and post-Python command line options, which help us execute code when we start VRED from the command line. With this parameter, we can tell VRED to load a file and simply save it as another file format by changing the file extension. In this example, I want to go a step further. I want to automatically convert all files in a directory to another file format. We start with a new Python file and define variables that configure our script. We define the path to the VRED Core executable, and we define the file extension of our source file as well as the directory where to find them. We also define the file extension of our target files and the directory where they should be saved. Notice how I use Windows-style paths here and use the R keyword to tell Python that the string should be read exactly like it is defined here. Otherwise we would have to escape the backslashes. I also have to create the target directory if it doesn't exist already. After this, we can start iterating over all files in the source directory. We only want to process files with the correct extension, and I extract the file name without the extension to build a file path to save the converted file. Then I build the file path for the source file and the target file. This has to be done because the variable file name only contains the file name and not the whole path. We have to be careful with the file paths here, because VRED only uses Linux-style file paths internally. The Python function join, however, will return a Windows-style file path. This is why we have to replace all backslashes with the forward slashes before we can use the file paths. Last but not least, we start VRED Core with the subprocess function call and add the pre-Python parameters to convert our files. When we run the script, all files from the source directory will be loaded in VRED and saved as another file format into target directory. You already might suspect that this is not the most efficient way to automate a task with VRED Core. This is because for every file, our script will start VRED, which takes some time, processes the files, and closes VRED again. This is fine for a handful of files, but if we want to process many files in a short time, this script has too much overhead. But don't worry, we will fix this in our next example. Let's have a look at batch rendering, or to be more precise, how we can customize automatic rendering in VRED Pro. You're often faced with the problem that you have to render a lot of frames with different combinations of viewpoints and variants. This is quite easy in VRED Pro, because you can use the render settings to tell VRED to render every combination of variant sets and viewpoints in your sequence. But of course, we want to achieve the same result in VRED Core with a Python script. Again, we start with a new Python file where we add our code that will render all of our combinations of viewpoints and variant sets. At first we define a few variables that tell the script where the VRED file is located, which variants we want to use and which viewpoints we want to render. We also define a path template that we use to generate a new file name where we can store the rendered image. Next, we load the VRED file with the load function and start iterating over all viewpoints and variant sets. This will, one after the other, select this particular state in the scene and then render the image with create snapshot. Here we fill our path template we defined earlier with the name of the viewpoint and the variant, and we also set a rendering resolution. This Python script will render all our images for us, but we somehow have to import the script into VRED. In the previous example, We use the pre-Python command line to execute our Python commands in VRED, but we cannot simply write each line of our Python code one after the other. Instead, we have to use another method that the Autodesk engineers implemented, base64 encoding. We can take our whole script and encode it in a base64 format. This way, we can pass this encoded script to the pre-Python parameter, and the whole script is loaded just like a regular Python file. There are online services where you can encode a text or a file as base64, and you could take the result as a parameter for VRED. This string of letters and numbers is the same code, just encoded so that VRED can understand and read it as a real Python code. We could just copy and paste the base64 string in the pre-Python parameter, but in this example I want to show you how you can encode the VRED script directly in our Python script. To do this, we have to surround the Python code block with triple quotes and store the text in a variable. The triple quotes ensure that the code block is interpreted exactly as it is written here, line by line. The script has to be a valid Python script, so whitespace and everything has to be correct. Otherwise it will throw an error when VRED tries to run it. Now we can use that variable to encode its content to base64 with this line of code. The last line will start VRED Core with the parameter pre-Python and the encoded Python script as an input. We only have to add some missing imports at the top and are ready to go. Running the script will take a while, but in the end we should have rendered 9 different images of our scene. Okay, so we can import a whole Python script into VRED Core with base64 encoding, which is great. But the way we did it in this example still has some downsides. The main downside is that the VRED Python script is in the same file as the automation Python script. And as you can see, our IDE doesn't show the normal Python syntax highlighting when we put the VRED script in quotes. The script is just hard to read and maintain this way. Therefore, we will optimize it a bit further in the next example, where we'll show you how you can automate optimizations in scene geometry. This time, we will need 2 Python files, one containing the VRED Python script, and the other one is to start VRED Core with this script as the input. In our VRED script, we start like in the data conversion example and define variables for a directory that contains the unoptimized files and one for the optimized files. Of course, we also have to create the directory if it does not exist yet. We iterate over the unoptimized files, create a source and a target file path, load the unoptimized file, and apply our optimizations. These optimizations are defined in the VROptimized module in the Python API 1 of VRED. You can find the documentation online. There are lots of optimizations you can apply, and depending on your geometry and your use case, these optimizations will of course vary. These 2 options I chose are just an example here. At the end, we only have to save our file to the target file path. When all files have been processed, we can terminate VRED. So, this script will be directly imported into VRED using the same base64 encoding method like in the previous example. But this time, we start VRED from another Python script to keep them separate. In our second Python file, we define the path to VRED Core, and we also define a path to the directory where the 2 files are stored. This can be done with the file attribute of this Python script that contains the whole path to exactly this script when it is executed. Then we open the VRED script file that we just created and that is located in the same directory and read its content. And then we can encode the file content as base64 and start VRED like in the previous example. Separating the VRED script and the automation script has the advantage that you can reuse in the VRED script in other pipelines, and you have the full advantage if developing in an IDE like Visual Studio, like syntax highlighting. In this example, you can also see that we start VRED only once and then process all files inside the running VRED instance, which is much more efficient than starting VRED for every file we want to optimize. So you see, there's a multitude of ways to automate and script rendering or data preparation pipelines in VRED. This can be done with Python, but also with other scripting languages like Bash, Shell, or whatever you like. This totally depends on the task, the use cases, and the development environment you use. But the underlying principles are always similar. You use the pre- and post-Python command line parameters to inject a Python script into VRED, which does the processing for you. And these Python scripts can use the whole range of functions defined in VRED's Python API. I hope I could give you some starting points how to script your first automated VRED pipeline. That's it for today. I hope you enjoyed the scripting tutorial, and I'll see you next time.